Hello, here's how to construct an elliptic line through any 2 points. First, we're going to make elliptic space. So there's the center of the space. We always call it O. Elliptic space is a circle and all the points inside of it. So here's a circle. So we've just made elliptic space. Now let's get 2 points. All right, I'm going to choose this point here. I'm going to call that point A. And let's get this point here. I'm going to call this point B. All right, now the elliptic line that goes through those 2 points is the arc of a circle that goes through antipodal points. Antipodal points are going to be at the end of a diameter. So there exists a circle through these 2 points, and this circle goes through points at the end of a diameter of the space. So points at the end of the diameter of the space are like this. They're at the ends of a diameter. So I need a circle that goes through the endpoints of a diameter and catches these 2. Seems like an impossible problem. Like there's too many weird requirements, but the solution's easy. I'm going to make one long extended diameter, AO. I'm going to extend it past O. Now this is actually an elliptic line here. The diameter that's in the space is an elliptic line, but it doesn't catch point B, so this doesn't satisfy what we want. And then what you do is the following. You reflect the point A across the center O. And I mark that, and I call that the point Z because I'm reflecting it across the alphabet as well. So that's the point Z. Sorry, that looks like an S, but pretend it's a Z. It's a Z. All right, now I'm going to do a thing called the inverse of point Z. So what I do is I make a perpendicular to the diameter at Z. Now I'm doing a really cool trick here. I think you can see it. I'm using a clear plastic ruler, and when I line up, in this case the 4-inch mark, with the red diameter line, I get a nice perpendicular without having to draw it the long way. So I do that much. And then I go from O to the point where that perpendicular hit the boundary circle. And then one more perpendicular. I line up a mark on my ruler, tangent to the circle at that point, and this point right here, that point right there should be Z prime, the inverse of Z. So the meaning of inverse, it's in the book. The distance from O to Z times the distance from O to Z prime would be equal to a radius squared. We don't care about that unless we need it for a proof. But here's what happens now. Any circle through A and Z prime is guaranteed to go through antipodal points. How cool is that? Isn't that cool? Any circle through A and Z prime goes through antipodal points. And then if you have a circle that goes, let's say it's an elliptic line AB and it goes through antipodal points, guaranteed it goes through Z prime. So this is all in the beginning of chapter 3. You can go find it and read about it, but this is a construction you have to be able to do. Now I need a circle that goes through A, goes through B, and goes through Z prime. So the way to do that is 2 perpendicular bisectors. I'm going to do a perpendicular bisector of AB. All I need is the perpendicular bisector of that, and it goes like this. You have to have your compass be more than half the length of the segment that you're bisecting. And now draw this bisector nice and long and in the direction of where you expect the center to be. See, if I want a circle that goes through A and B, its center is going to be over here somewhere. So I draw that perpendicular bisector way over here. Now I'm going to do the perpendicular bisector of, let's say, BZ inverse. So I do BZ inverse, perpendicular bisector. All right, so I want the perpendicular bisector of that segment. So I have to make my compass more than half the length of that segment. And I'm going to make some arcs above and below it. And here we go. Ba-boom, ba-boom. Now I really only care about where this perpendicular bisector intersects the old perpendicular bisector. So if you notice, I didn't have to draw that whole perpendicular bisector. I might mark these two intersections to show I used them. And then here's the point I care about. I'm thinking, if I did my construction right, a circle centered here, let's call it C for center, a circle centered at C, going through A, has to catch B, has to catch Z inverse, and it's going to go through antipodal points, which makes it an elliptic line. So let's see if we got it right. I'm trying to get that point right on there. I set up my compass to catch point A. Does it catch B? It certainly does. Does it catch Z inverse? Check it out. It's doing great. So I'm going to draw this circle. And here's the part that's the elliptic line. This part right here, from here along here, catches A, catches B, and stops here. That's an elliptic line because it has to go through antipodal points. I built it that way. Let's just verify. Yep, when I catch these two endpoints, it goes through the diameter. Now I missed by 1 millimeter, but when you do it perfectly in Sketchpad, it's gorgeous. And in Sketchpad, it's a much easier thing. So give it a try. And if you're studying along with me this summer, try this construction in Sketchpad. So you download Geometry Sketchpad and try and do this construction. This is a crucial construction because that means you can make an elliptic line anytime. This also gives us a nifty shortcut. If you ever have an elliptic line and you need to get the reflected inverse of a point like Z prime, but you have an elliptic line, then choose if you need the reflected inverse of A, just do AO, and it's going to catch that point Z inverse. So you can automatically get a reflected inverse if you ever need it, which is handy because any line through A, any elliptic line through A has to go through Z prime. So we'll be using that idea in the future. All right, well, there you go. Your first research assignment. Try and do a construction like this in Sketchpad.